now? Still okay? Okay. I realize I talk really fast, so you're allowed to throw things at me if I go too quick. So just put it out there. I know I talk quickly, and you're allowed to throw things and I can dodge real quick, so you won't injure me. So that's out. Who in the audience has heard of the Metasploit project? Awesome, great. Okay, I wasn't sure how deep to go with some things, and that gives me a better sense of what I should cover, what I should not cover. Who has used Metasploit 2.6 or 2.7? Who has used Metasploit 3.0? No, it doesn't exist yet. There's some version, but it's not actually published. So it'll be published hopefully tomorrow. We'll see how that goes. We're still working on that. I was actually trying to do a 3.0 release for FOSDEM, but between my luggage being lost for about 30 hours and other slides to do, it didn't happen. So hopefully this week, that 3.0 final will go out. And honestly, the biggest problem we ran into was the Windows support. It's trying to get the freaking Windows users something they can use. And I gotta tell you, for open source projects, if you don't support Windows, you're losing out on about 98.99% of your customer base. And it's ridiculous. There's so many people who just will not use anything other than Windows for their testing and their day-to-day stuff. So if you do an open source project, make sure you at least try to give some kind of Windows support, just because you've got that many more users and bugs and reports and so on. So anyways, with that, I'll start the talk. So quick, who am I? My name is H.D. Moore. I am the founder and lead developer for the Metasploit project. I'm also director of security research for a company called Breaking Point Systems out of Austin, Texas, where we build network test equipment. And I'm sure most people will find it very interesting, but basically what we do is kind of Metasploit done in hardware at 10 gigabits per second with lots of crazy processors. So that's what I do. It's my day job. And it's lots of fun. It's one of the few companies I've worked for that actually support my open source projects, and I'm appreciative. So why do you care? Why should you listen to me yabber today? Well, Metasploit 3 is basically done. It's a tool you can actually use today. There's a whole other talk that I have prepared about licensing and open source and things like that, OSI approved versus non-OSI approved. And I'm kind of putting that in the back burner. If you want to hear about that stuff and kind of why Metasploit's license has been changing, feel free to talk to me after this talk, and I can give you the other presentation with my laptop personally outside of the room somewhere. But basically, most of Metasploit is still BSD license, and that's the important part. We call that the Rex library, the Ruby exploit library. And finally, you'll see the latest in exploit technology and kind of what we're doing with Metasploit and kind of the new shiny things you can do with the new version. So the Metasploit framework, it's an exploit development platform. And by that I mean it's actually everything you need to create, test, use, debug, and have a lot of fun with exploit code. So if you're working on a new vulnerability or a new overflow or a new exploit, or even exploiting something like a web application, you can use Metasploit to build those exploits, test it, and make it reliable. And best of all, we reduce the amount of code you have to write exploit code. So instead of having to do things like have your shell code hard-coded into your exploit, or have to track what targets are supported, or all these other things that you have to normally write as part of exploit code, we do all that for you and make your code much easier to maintain. So that's good for everybody using your code. It's good for you because you don't have to worry about maintaining your code afterwards, and it makes sure that all the new features that go into Metasploit will be compatible with your exploit in the future. So when we add a new payload to Metasploit to say, pop up Clippy on the screen and make them dance around or something like that, your exploit will be compatible with our dancing Clippy payload. And that's one of the benefits. The people who use Metasploit are security researchers, of course, people who do exploit development and find new vulnerabilities. It's a great platform to use because one, it's free, and two, it has a lot of code for funky protocols like DCRPC and SMB for finding vulnerabilities and testing them. Anybody doing penetration testing for security on a security team inside of a company, or working for a security company pen testing other clients use Metasploit a lot, mostly because it has slightly different coverage from the commercial tools. We don't say we have more coverage or better coverage, even though in some cases we do, but we have a different set of coverage. So if you use something like Core Impact, who here is familiar with Core Impact? Wow, okay. They must not have good European marketing. It's a company called Core Security Technologies, and they were based in Argentina. They didn't move their headquarters to the US, and some really smart guys. They've got Ivan Ars and Guerra and Giuliano and all these really, really great hackers that get to spend all day long working on exploits. Unfortunately, they charge something like $25,000 a seat for their product, and so not very many people can use their product because it costs so much. So I was actually one of the beta testers for that in 2003, and I couldn't afford Core Impact, so I started working on Metasploit. But they're definitely the inspiration. They're the originals. They do the best job. They have had years more development experience than that. But unfortunately, the product only works on Windows, which is another reason why even if I could afford it, I couldn't use it because I had to run Windows. And it wasn't worth at the time booting VMware just to run some pen test tool. Anyway, so security vendors are actually using Metasploit now to verify that all their security products work appropriately. So that's anybody who does IPS development, intrusion prevention systems, anybody who has kind of a box that runs on the network that protects attacks coming across the network. They'll use Metasploit to verify their system actually protects against those attacks. And that puts us in a really cool position. Since Metasploit isn't really a corporate, it has a company behind it. Sorry. So yes, you're supposed to throw things at me when I go too fast. You can throw anything, but I'm going to go slow anyways. Thank you, Chris. So security vendors, anybody who makes an IPS product or IDS product using Metasploit to verify that their blocking technology actually works. And what they came to realize is that it doesn't for most of the vendors. So they'll say, well, we have our new IPS 1000 that'll block all exploits coming into your system. And then they just run Metasploit through it, and somehow Metasploit still gets through. And they wonder what happened. And so on our side, we make sure that no matter when a new exploit comes out, that our exploit is one, reliable, and two, passes through most IPS systems by default. And that's good because it makes the IPS developers work much harder to make better products. And anytime there's a new evasion technique, we can force the entire industry to upgrade their products just by putting it into Metasploit. Because now we go from, okay, here's this theoretical way to bypass an IPS, to, okay, now there's 90,000 users using exploits that bypass your IPS. So it's a great way to leverage our user base as Metasploit to force IPS vendors to act more responsibly and to fix really stupid vulnerabilities in their products. So we see Metasploit not only as a tool for development and testing, but we're also forcing the industry to produce better quality software. And we believe we do that with the security vendors right now. And of course, script kiddies. Anybody who wants to go exploit lots of systems, you can use Metasploit to do that, and it's lots of fun. And eventually, those script kiddies will also become the people doing security testing on your network. So as annoying and stupid as they can be, you still have to be nice to them, because someday they'll be the real security testers that you have to hire for insane quantities of money to do testing. So that's our user base right now. Some quick history. In 2003, I created the first version, which was crap, as many people told me. And the nice thing about open source is when you release a product and you start getting feedback and everyone tells you you're stupid and they can write it better, you can call them out and say, all right, well, do it better then. And that's what happened. A hacker by the name of Spoonan came up to me and said, your software sucks, you're doing this all wrong, you don't know what you're doing, you're a horrible developer, your stuff sucks, go away. And my response was, all right, man, we'll fix it, do it better. And it's like, all right, well, I will. And you get the whole ego thing there. And about 6 months later, we came out with 2.0, which is much better. So it worked. And it mostly went with me saying, hey, Spoon, your code sucks. No, it doesn't. And he does it better. So it's a great way to get motivation in the open source community is to challenge someone's ego and say, no, I can do it better than you. And that competitiveness results in a much better quality software at the end because of that. That actually exploit tool was originally called, I think it was like BFG or BFE or something like that. But basically it was like big F exploit gun. So it was just supposed to be a tool for firing off exploits, and eventually became this giant thing that it's evolved into. And it only had about 15 exploits, this kind of crappy curses UI on it that no one really liked, and we threw that all away. And starting with version 2.0, we created this, real structure and libraries and modular format and all these different things for basically making exploit development easy and not having to have a lot of boilerplate code inside of each exploit. So the exploits could be as small as possible while still being maintainable. And one of the things that kind of made that problematic is that we decided to use Perl to do that. And if you're looking for maintainable code, as a Perl developer for 8 years, I can write pretty clean Perl code, and I still have trouble recognizing what the hell I wrote 4 years ago. So we decided that when we rewrite this thing again, we're going to pick a different language that is hopefully easier to read, easier for other people to contribute to, and even if no one else likes the language, screw them, they didn't help much anyways. So that's our approach. As much as you want to have the community contribute to your software, don't make language decisions based on other people contributing to it. Pick a language that you're going to be able to run with and be able to do all your development on that you like to write in, because you can't really count on that community support, especially not for large projects. And that's just my experience. So for 2003 to 2006, version 2.0 kind of trundled along, and we kept adding new features to it, and kept adding new things to it, and ran into kind of a couple brick walls in terms of development, where we could not add a new feature because it broke something else, or was really hacky how we had to do it. A good example of that is Perl's object-oriented support. Has anyone used Perl's OO stuff or anything serious? Cool. Well, you know the problem then. It has OO support, just like C has OO support. You can make it act kind of like an object, but all you're really doing is calling a method on a pointer when it comes down to it. And that's how it works. So we decided that, Python, it looked kind of nice except for, caring about white space and not really being object-oriented, even though it has methods and functions. The fact that you do len, parentheses, string, as opposed to string.length, just boggles my mind that you have to do that in Python at the time. So we decided to go with Ruby. So Metasploit 3.0 as of now is just about 100,000 lines of Ruby. As far as I know, it's probably one of the biggest Ruby projects in existence. It just keeps growing and growing and growing. So we wrote a lot of freaking Ruby in the last 2 years. On top of that, we've got about 53,000 lines of C and C++. Most of that is things like our payloads, our modified version of real B and C that we use for one of the payloads, the interpreter payload I'll go into a little more in a second, and about 8,000 lines of assembly across piracy, RISC, MIPS, x86, x64, all these different CPU architectures. We had to write different shellcode payloads in. It comes out to about 8,000 lines of assembly total. And those are actually written in, we have a standard API now for our assembly and our shellcodes, which makes a lot of things, a lot of the payload systems easier to use. Total modules, if you look at all the payloads, all the encoders, the knobs, the exploits, you end up coming out to about 350 unique modules right now in the public source tree. And if you pull in our private trees, it's probably upwards of 450 or 500 now, just because we haven't finished a lot of code yet. And about 2 years and about 3 developers really kind of going full-time on that. So it's a huge project, and hopefully it doesn't suck, and feel free to tell me if it does. So, why Ruby? I kind of went into this earlier, but it's clean, it's easy, it's fun, it's not stupid like Python. Apologies for Python developers, but I hate the white space sensitivity. Like, I don't want to care what editor I'm using when I'm writing code, and I don't want it to puke up when it sees a tab versus the space. I'm sure someone will argue to the grave about that and what's better and what's not, but we thought this was better. The OO model is awesome. It actually is real OO. You can extend any object at runtime, including all the built-in classes. And that was huge for us because we do things like extend the string class to have new, shellcode functions, things like that. And in Metasploit 2, the way that we did our payloads is we actually had, there was a child inherited from a parent, and the parent randomly imported the namespace of the grandparent at runtime depending on what options you set. So we basically had to keep scraping the symbol table in Perl, trying to hack in new features and import new classes. And we got around that in Ruby by using the mixin support and basically not really using normal inheritance, but using mixins and modules and some class inheritance, but mostly mixins. So it was a great way to do it. Ruby's writing isn't native. It all runs in process. Basically, Ruby is a giant select loop, and that's how it processes its threads internally. And that's good and bad. It's bad because everyone complains saying, well, blocking operations block the whole process, and there's all these other issues with using green threads, but it also means that anytime you use threading support in Ruby, it'll work the same on every single platform that Ruby supports, which is great for us because we try to support everything under the sun. As of yesterday, someone actually has Metasploit 3 running on the new Nokia N800 platform, and they're actually owning systems with the DCOM exploit with their little Nokia. So we thought that was really cool. I've got the Nokia 700, and while I can get Metasploit to work, it takes about 45 seconds to start up, and trying to type that little keyboard, I can't stand it. So the N800 seems a lot better, and a lot of the problems with the hardware have been fixed, it's much faster. And Ruby's supported on all sorts of platforms now. The next version of macOS X is going to include Ruby on Rails. Windows, Ruby support's awesome. The installer out there is great for it. You can basically build your own custom Windows Ruby install in about 5 minutes with the proper compilers. And Linux, of course, which is their dev platform, works great. So this is kind of a quick diagram of the architecture. It's pretty similar to Metasploit 2, where you basically have 3 levels of libraries. At the very top, you have this magic Rex library that's licensed under BSD, and that's where really all the useful, important code is. So anything that we feel someone else should be able to reuse or we feel is useful to another outside project, we stick into that library licensed in BSD, so anyone on the planet can use it. Below that, you've got the MSF core license, which provides basic things like, how to encode certain types of shellcode, things like that, things that are really Metasploit specific. And then finally, you've got the MSF base stuff, which provides basic user interface classes. and gives you just kind of basic tools for creating your own exploit tools using these classes and using these libraries. And of course, below that, you've got all the different types of modules. So you've got payloads, you've got exploits, encoders, no-op generators, auxiliary modules, and we'll get into those a little more specifically next. And of course, you've got tools that can tie directly into the Rex layer, you've got plugins that tie directly into the MSF base layer, and you've got all these different interfaces that are tied into the framework. And it was really easy for us to add a new user interface. It's really about 3 lines of code to create a framework instance, pick a module, and run it. So if you want to build a custom tool for doing exploit development or any kind of testing, it's really, really simple. It's not very much Ruby at all to be able to create these new instances and do testing and scripted and programming. So Rex library, the big things that this library accomplishes are text manipulation. When you're writing exploit code, one of the most common tasks is just generating strings. It's all those buffers you send across the network that you use to trigger overflows. How many people have seen exploit code and seen this long string of A's somewhere inside the buffer? Like just, stir copy, A star, memset, OX41, or whatever it happens to be. All these exploit developers somehow think, 41 is the magic character you're supposed to use for all these exploits. And what happens when you do that is the IPS vendors and all the security vendors go back to their shop and they write a signature for your exploit that has a whole bunch of A's in it too. So one of the things that we do is make sure that we never have static strings in our exploits. Every exploit is unique and beautiful like a snowflake every time you run it. So that should ensure that anybody who has a signature is looking for the vulnerability and not looking for our exploit. So sometimes hackers like to do things like put their handle into one of the strings or put their name somewhere in the exploit. And we think that's all great and all, but we don't want to make our exploit vulnerable to signatures. So we remove all those things when we import into Metasploit. So when a Metasploit exploit sends something on the wire, we try to keep that as bare, as clean, as random as possible, so only the important pieces stay the same. So the text manipulation libraries in the Rex library allow you to do things like generate alphanumeric characters or generate any string within a certain character set and make it all random and clean and whatnot. And that also serves as kind of a quality assurance for all of our exploits, because every time we run an exploit, the strings are all a little bit different. And so if a lot of exploit developers will create their exploit, send a static string, and not realize that their shell code just happens to work because they missed a certain character. But if you put another character into it or change the shell code just a little bit, it would all fall over and crash. So by making everything random every single time we run the exploit, we make it really easy to verify our exploits will work under almost all conditions. Additionally to the text manipulation, you also have things like CPU instructions, basically how to decode instructions and generate new instructions for different platforms. So in your exploit, if you say, I want to have a short jump, so I want to jump forward my opcodes by this many bytes, instead of having to write the opcodes out manually, you just say, I want an x86 short jump, and it does it all for you. So it's just kind of nice shorthand for doing assembly inside your exploits. Who here likes the way that most sockets are supported under programming languages? Yeah, that's what I thought. No one really likes the implementation. The socket API doesn't really extend to how people use sockets. Everybody who writes a networking library, especially when it's like a stream protocol like TCP, we have multiple segments and a record can end in the middle of a segment followed by another record, things like that. There's really a clean way to do it. You have to create all these little while receive loops and timeouts and selects and polls, and it's just kind of a big pain in the butt for anybody who's doing socket operations. So we decided we didn't like that, and we created this super socket class. And this socket class supports everything from built-in SSL to being able to specify what the source port and source addresses are, to actually supporting proxies built into it. It supports SOCKS4 and HTTP, and they can chain them together. So in one case, we actually tested using our socket class with 500 different proxies all in a big chain, going through like secure shell with the -D option, going through HTTP proxies we found on the internet, and about 35 seconds later, a request actually came through from all 500 proxies. So it was awesome. It was like, so our socket class actually works, and we tested the proxy support really well. So if you ever need to write a quick application that's really dirty, that does something using a socket, and you want to use proxies, you can just use the Rex library, and it's under BSD, and it's a great tool for doing socket programming in Ruby. Additionally, we support things for file formats. So if you want to generate a Windows PE image, like an EXE or a DLL, you can use our library to generate those on the fly with whatever code you want inside of them. So we use that for our exploits. So we can serve up a magic executable to somebody that has the shell code you selected as part of the exploit. Additionally, we allow you to read that format, so you can use things like the MSF scan tool to analyze a DLL or EXE and to find things like version information or return addresses inside the DLL, things like that. So all the libraries for reading and writing that format are there, in addition to a couple other formats. And we plan on adding ELF support and the OSX, Mongo support, and so on in the future. And finally, this is kind of the big area we put a lot of code into, all different protocols supported by the Rex library. We basically have our own Samba client written in Ruby as part of this library. And just, I mean, I worked on this thing for probably 4 months, just this library alone. And it's, it's huge. You have to support everything. You have to do, the way the library is now, you can actually connect to a server, authenticate using ATLAM2. You can list files, read them, write them, whatever you want to do. And not only can you do all these cool things with just like Samba with support, but you can do really evil things to the protocol. So if we just went to the Samba library and wrote a wrapper using, like, say, Swig or something like that, you wouldn't be able to control all the specific fields inside the SMB packet themselves. However, with our code, you can. You can do all these things that actually break the protocol, or do really evil evasion things using our SMB library that aren't possible using anyone else's library on the planet. So if you want to write any tool that talks over this protocol, you can use this library and then do it in a way that no one can really detect very well or process well and kind of slip under the radar of a lot of systems out there. The same thing applies to our DCRPC and our SunRPC and our HTTP support. These libraries are designed to give you maximum control over how the data ends up going out on the wire and be really clean and easy to use for exploit developers. And in addition, these protocol stacks also support really deep IPS evasion built into them. They allow you to do things like pad out SMB headers and do fake pipe names and all kinds of evil things inside the protocols that just make it a pain in the ass for anyone to really detect attacks being sent using these stacks. So Metasploit modules. I mean, if you look at any of these projects out there that support dynamic modules, everyone has a different format for it. Half the folks use like a little XML file, and others use some Ruby file or some Perl file or some other kind of standalone little script. We decided that a module should just be a simple Ruby class. So every module is part of Metasploit, whether it's a payload or an exploit or a not module, has a unique class somewhere. It's under some namespace. And right now it's based on the directory structure, and we use that to determine when a module is loaded and so on. Every module has a set of meta information that is standard across all modules. So every module has a license field. We can tell you what every single module in the framework is licensed under with one quick script. We can also tell you who wrote that module and when it was written and what the revision number is, all these different things that we track, descriptions and so on. And that's makes it easy to work with these things, easy for us to load new ones and track them and so on. Each module type exposes different methods, and those methods are based on which module class it inherits from. So exploits act one way, payloads act another way, and so on. And we expect certain methods to be there for certain types of modules. So exploits are simple. They're just a standard module that inherits from MSF exploit class. They use really heavy use of Ruby mixins. So your exploit will inherit from the basic exploit class. Then it'll say, I'm an exploit, but I also want to use the TCP protocol. And what happens is all you have to do is include the, I think it's MSF exploit remote TCP class, and all of a sudden your exploit now has all these new options. Those options are things like, what is the remote port that I talk to? Should I use SSL? Should I use proxies? Should I send my data really slowly across the network in little tiny bits, or should I send it normally and fast? Everything that protocol will support automatically gets loaded into your module just with that include line. So you don't have to say that your exploit needs a remote port to talk to. That's already handled just by including that mixin. The same thing applies for things like UDP and SMB and HTTP. Anytime you say, I want to talk in this protocol, it includes all the different fancy evasion options for you automatically. So your exploit code doesn't have to know about any of these new evasion methods. It doesn't have to know, whether our socket class supports this kind of proxy or that kind of proxy. It's all done for you just by including our mixins, and they do the rest of the work. Mixins can also define how the exploit itself functions. You can have an active exploit, which is your normal standard, I'm going to run my exploit, it's going to go break into something and give me a shell. And it's kind of serial, straightforward, go do this, done. You can also have passive exploits. These are exploits that kind of listen for something. An example would be something exploiting the Microsoft WMF vulnerability. It'll listen for connections, and anytime a web browser connects to it, it'll serve up an exploit page for that client, and then they keep going. So in that case, as each new client connects to the exploit and does something with it, we'll keep getting command shells and just popping in the background. So you just kick the exploit off in the background and just watch all the command shells pour in, interact with the ones you want to, and kill the ones you don't, and so on. So it's kind of when you're doing massive exploitation of a huge network, this lets you kind of manage and track all your exploits and your shells much easier than you have to do normally. You can also do things like brute force. So we have a mix-in that's basically called brute force, and very generic. But that says instead of calling the exploit function in your module, we call it exploit_target function. What that does is every time, and that includes, when you include that mix-in, 3 new options are available. That's the return address, the how far to step between each one, basically the start address, the stop address, and what offset to step between them. And your exploits function will be called once for every offset between those things until a shell appears. So it automates building brute force exploits. All you have to do is create a little stub of code that says exploit target and do your exploit for that target, and it handles everything else for you. So it's just a quick way to build common types of exploits and reduce the amount of code you have to write as a developer to make your exploits work right. Finally, we started adding different kind of protocol and stack support. So recently, does anyone remember that we added the wireless support, or saw our wireless support stuff in Metasploit 3? Okay, well basically there's a library called Lorcon, and it was written by the guy who does Kismet, and then a friend of his, which is Josh Wright. And that library is really cool in that no matter what type of wireless card you have in your system in Linux, it'll give you a way to do raw 802.11 transmits out of it. And all kinds of cool exploits become possible when you can send raw 802.11 frames. You can do things like send fake beacon requests and send fake Chrome responses. And during the month of kernel bugs project that I was helping out with, we found something like 20 or 30 different wireless card vulnerabilities just by running really boring Ruby fuzzers we wrote in Metasploit for this thing. And as an example, I went to the local electronics store and I spent way too much money and basically bought like 15 or 20 little USB cards and took them home and just plugged them one after another into this poor little Windows laptop I had sitting there, and then running the fuzzer on it until I got a shell. And out of those like 20 cards I bought, I probably have exploits working for about half of them now. And I actually then went back and returned all the cards, got the money back. And now I've got working exploits for all these consumer cards. So that was our methodology for that. We go out, buy a bunch of cards, test them, write our exploits, and then get our money back by returning them all. And you can do that forever. So that's actually once a month I'll do a couple more wireless cards. Because there's so many vendors and there's so many different drivers, and they're all broken as hell, so it's easy to just keep doing that. And what we noticed is that wireless card vendors don't really provide updated drivers for old equipment. So they'll release one driver for one card, and that's it. They will never touch that driver ever again unless, a bolt comes down from the sky and electrocutes them. Like, there's no reason for them to come back and look at it. So if you bought a certain model of a wireless card and you plug it into your Windows computer, you are exploitable no matter what from now until the end of time until you remove that card. And even better, if you decide, well, I'm a cool Linux guy and I'm going to run it on my laptop, but crap, there's no open source driver. Well, I'm going to use Indus wrapper because that's really cool. Well, guess what? The driver is still running on your laptop in your kernel as Linux, and it's still exploitable. So if you use any of those Indus wrapper wireless drivers, more than likely your system is exploitable using the stock Metasploit fuzzer. So anyways, just kind of a fun aside from doing the Wi-Fi stuff, is that most of the folks who thought they were doing great because they use Linux are still exploitable because they're still using Indus wrapper and actually the Windows driver in their Linux kernel. We're also planning on adding Bluetooth support to exploit some of those vulnerabilities, and we do have a PCAP module that's actually based on the real Ruby PCAP, but it's less stupid. It decodes 802.11 and things like that. Oh, and those extensions, the Lorcon, the Bluetooth, and the PCAP are all GPL licensed because that's what the dependent code is licensed as. So here's an example of an FTP exploit in Metasploit. Now, this module would say, I want to include the FTP exploit class. And this is all the code for actually running an exploit. That's all there is to it. So it's pretty small. I mean, sure, it takes about 5 minutes to write that and then test it and make sure it works, but that's basically all there is to it. The first line, just connect. That means whatever my module is doing, connect to whatever the service is supposed to be. In the case of FTP, it's going to say, I want a remote port, and that port's going to default to 21. So if you're testing a normal FTP server, that all works for you. And if something goes wrong and that connect fails, Ruby's going to throw an exception, which will cause exploit to exit out, and it's all handled, cleanly. The next line is pretty obvious, just print out what target we're trying to exploit based on what target the user selected. The next line, where it's buff equal rex text, that just means generate some big buffer of 1,816 characters and stick it into this buffer. So it's straightforward. The next line uses the generate SEH payload function. And on Windows, if you're exploiting an SEH pointer overwrite, which is a really standard thing on Windows, most buffer flows on Windows are actually SEH overwrites, not return address overwrites. And a lot of folks don't realize that, but that's why Windows exploits are so damn easy. It's because SEH is cool. It's like the global error handler for your application. When something goes wrong, that pointer is always being called. So you can exploit something like a memcopy, def, source, -1, which comes out to trying to copy 4 gigabytes of data. And you can still exploit that in Windows because of the way SEH is handled. But that's much deeper talk. Basically, this SEH routine will generate a short jump in assembly, followed by a return address, followed by your payload, all at once and all done for you. And then we stick that payload in, we stick that SEH frame and that payload into the buffer, and then we send it with the user command below that. And then we call the handler, and then we disconnect. And that send command function will go do all sorts of different things with that command. So if you say, I want to do FTP evasion using telnet opcodes, it'll take that user command and do user space and that buffer, but for every single byte of that buffer, it'll also do ASCII FF and then some random byte, which the FTP server will likely ignore. So the buffer becomes, instead of 1,816 bytes, it ends up becoming, double or triple that from all the different evasion opcodes put into it. So all the different IPS evasion techniques are automatically done for you just by calling the code this way. And of course, handler, if you're doing like a find sock payload, you need this handler call there to find the shell on the socket and so on. But that's all pretty straightforward. So Metasploit payloads, it's the same thing. It's just a different class you inherit that have slightly different methods. And there's 3 different types. You've got singles, you've got stagers, and you've got stages. So a single is just some payload that is a big buffer of data that gets processed as a payload. That could be your standard, bin shell. That could be your standard Windows bind shell, whatever you want it to be. It's just a big block of assembly that is sent over as part of the shellcode. A stager is just the first part of it. It's just enough to be able to get a connection back to the attacking system and then send the rest of the code over. And the stage is the code you actually send over when the connection is established. So we have kind of the standalone version. Then we've got the first part that is the connection back to us, or the connection for us to them. And then we have the actual code we want to run. And what happens when you start a Metasploit is it automatically cross-references all the stagers with all the stages. So if you come up with a new little assembly stage that does something really cool and evil, like let's say disable the Windows firewall, all you have to do is add a new stage module, and you'll automatically get 50 new exploits depending on all the different stagers. It'll cross-reference yours automatically with every compatible type of stager and make it available to the user. So it's a really clean way to do shellcode development, and there's a standard API and so on. In addition to the standard, command shells and so on, we have DLL injection, which is really neat. We actually, when you're exploiting a Windows vulnerability, we can allow you to inject an arbitrary DLL into memory, never touching the disk, and run that DLL like it's shellcode. So if you're a really cool, happening Visual Basic developer and you want to write you some shellcode, you can do that. You can go write yourself some Visual Basic shellcode and use it with Metasploit if you really want to. And we promise not to laugh too much when you tell us about it. You can also do any language that you can write a DLL in, you can use as a payload now with Metasploit. And it's all standardized and easy to do, and there's a generic payload for injecting your own DLLs and so on. We also support things which are kind of non-standard payloads. For instance, like PHP payloads and command shell payloads. So for instance, let's say you've got a vulnerability in a CGI script, and it allows you to inject a command into a parameter. So let's say it's like a Perl open vulnerability, or a meta-character escape vulnerability, something like that, where you put the command you want to run to the URL and it goes and runs that. Well, we'll give you different types of payloads, and those payloads do things like bind a command shell, do a reverse connect shell, and so on. And the way it actually does it depends on what system you're exploiting. So let's say you're exploiting a Unix system and you use the Unix reverse shell payload. What it actually does on the server side is it runs telnet to your host and your port, and then pipe, and then bin shell, and then pipe, telnet, your host, and your port again. And on the Metasploit side, we'll accept both of those connections from the server, we'll glue them together into a console, and let the user type on it just like it's a regular old shell. But it's completely transparent to the user that there's really 2 different TCP connections coming back instead of 1. And for things like bind shells, we'll do things like we just run Perl in the background, and that creates a bind shell. So we use all different features available by the operating system to create these kind of like payload-like commands that you can use as generic payloads with anything else. So there's actually a new virtual payload that's kind of generic that's called bind shell. And no matter what exploit you pick and use that payload, it will automatically select a compatible bind-like shell payload, including the command ones, the PHP ones, and so on. The Windows payloads have kind of a standard calling convention, so if you want to write your own codes, interact with ours and work with them, you can basically just download the source and create your own payload really easily. One of the payloads we have is the in-memory VNC server. So we took the real VNC source code, we modified it so that it only runs in polling mode, it doesn't hook anything or load events. We made it a single DLL, it's completely standalone. And if you use this as your payload, what happens is, let's say you're exploiting like the decom vulnerability, and you want to use the bind shell connection to get your payload across. So you connect to port 135, you send your evil DCRPC packet, and then that opens up a listening shell on the server. And then Metasploit connects to that shell, does a negotiation, sends the entire DLL of WinVNC across, injects that VNC DLL directly into memory on the service host process, never running to disk, never showing anywhere else in the system, and uses that existing connection to do VNC across that connection. It doesn't create a new VNC server connection anywhere. And what happens is on the Metasploit side, it creates a new listener and then binds the current connection to the server through the payload to a local listener and then runs VNC viewer to connect back to itself. So, long story short, what happens is you set the payload, you run it, and 5 seconds later you're looking at their desktop and moving their mouse around. So it's a really cool demo. I'll do that in a couple minutes, so I'll demo that just as kind of an example. Another type of another type of payload we use that's based on the DLL injection is PassiveX. And has anyone heard of that before? Okay, so we use this great thing called Internet Explorer to do all of our payload handling for us. So let's say you're exploiting a system behind a firewall, and that system can't connect back to you directly. It can only go through a proxy. And that proxy, let's say it has a password. The password is the domain credential of that user inside Windows. So what we do instead is we create a payload that modifies the registry, removes all of Internet Explorer security, not that there's much to start with, but we clean up the remainder, and we start Internet Explorer and we point it at our own system that's running Metasploit. Now, it connects to us and we give it an ActiveX control. And it says, yes, run my ActiveX control. And then it does that. So then it starts running ActiveX. And then that ActiveX control proxies a TCP connection across GET and POST requests back to our own web server. And because we're using Internet Explorer, it reads the user's registry and uses their cached password to connect back to us through their own proxy. And so, even though they're going through authenticated, ISA proxy or Microsoft proxy server, even though they don't have direct access to the internet, we're able to get a remote working command shell or remote working VNC desktop via POST and GET requests over this ActiveX control through Internet Explorer. So that just kind of gives you an idea of the complexity that we go into with DLL injection and transport mechanisms and so on. And that was a whole lot of fun to play with. Unfortunately, it doesn't work with Internet Explorer 5 or 7. So unless you're using IE6, it's not going to work too well. We're working on improving that for IE7 and porting it forward, but we have to patch like 6 more registry items to make it work, and it makes the code much bigger. And finally, there's the Meterpreter. Has anyone heard of the Meterpreter before? Oh, you're missing out. This is like the coolest Windows payload in existence ever. So the Meterpreter is kind of this dynamically extensible payload. So we inject this DLL, which has its own communications protocol, supports native transport encryption, and allows you to load new extensions on the fly remotely through the connection to the server. So you can create your own DLL extensions that do anything you want to do in Windows, as long as they conform to our API and interact with them on the fly. We came up with a standard API extension that has all the features you normally need for a pen test. And that's actually the PS command, kill, ls, make dir, upload, download, execute, interact, all sorts of features. Basically, almost everything you can do from a Unix shell, you can now do to Windows through this payload connection that's written as a DLL. And the nice thing about that is you can create your own extensions, create your own, improvements to this thing, and load them on the fly. One of the neat features is the migrate command. That lets you take your current exploit inside your current shell, wherever that's running inside any process that you happen to exploit, and move it into another process on the system. And let's say the administrator sees you inside one process, like, hey, why is my, Internet Explorer process connecting back to my server? And they try to kill Internet Explorer. Well, guess what? You're still connected. You just hopped around to a different process. So it's kind of like a shellcode whack-a-mole, where every time they try to kill you, you pop into a different process on the system. And we're working on a concept now where we inject ourselves into 3 different processes and we all watch. And if any one of them dies, we elect a new process and jump into that one. So you can actually do the wonderful Windows API and the duplicate handle call. We can keep the same existing TCP connection to our payload and just keep bouncing around processes in the same system. So no matter what process you kill, we still have a connection. We never interrupt it. And we actually keep our state as we move around inside different processes. So it's a really neat way to kind of laugh at the administrator for a couple hours. Granted, they can reboot your system and kick you out, but then you just break in again and do it all over again until they run away. So Metasploit has this really nice API that allows you to basically drop to a Ruby prompt at any point and start calling the API directly. Or you can load new scripts into the system. And we have scripts that are already pre-made to do things like go through every process in the system, compare it to a known antivirus, and kill it. And every firewall, and kill it. And every other kind of security software, and kill it. And does it all for you. So you just say, I don't want any antivirus, thank you. And it goes through and removes them all from the system. And it's all scripted and automatic. If you use the Ruby API for this, you can actually mirror the hard drive to the server in about, it takes a while to do, but you can do it all in one command line, basically. We say, give me the entire C drive of the system I just broke into, and copy it over here, okay, thanks, bye. And that's it. So something I haven't really talked about much yet is the auxiliary module support in Metasploit 3. There's all these cool types of attacks that aren't really your standard exploits. There are attacks that don't really take a payload, that give you administrative access, that do trigger a denial of service bug, or a protocol buzzer of some sort. And we needed some way to include these. We came up with a new module format called auxiliary, which is basically anything you want it to be. It's a generic way to add cool code to Metasploit. And that's probably where most of our contributions come from now. Is anybody who has a cool hack or a cool technique that can add it as this type of module, and we'll take it no matter what the hell it does, as long as it's written clean. So I won't go into it too much, but that's kind of it. With the current version of Metasploit 3, we've got 4 different UIs. There's the console, which is really the way to use the system, and I'll demo that in a second. There's the command line interface, which is good for scripting, cron jobs, and any kind of mayhem you want to do just by running things through the command line. There's the web server interface, which is actually Ruby on Rails with Metasploit inside, so it's really neat, and I'll show you a demo of that. And we're also working on the new GUI for that, which is GTK2 based, and it's being led by a French developer who has been kicking ass on it, and hopefully will be done in the next month. I'm going to skip through some of these things. Basically, we have an event framework that's really cool. You can hook different operations and automatically do things, and certain things happen. You can create plugins that hook into the system that automatically add new features and integrate other tools with the system. And quick summary, and then I'll go to the demos. Advanced exploit framework, you can do just like anything you want to do with exploits using our toolkit. It's really simple to use, and hopefully we'll have 3.0 out next week. And if you want to get a copy of this right now, we've got a shiny new website up, which is framework.metasploit.com, and you can grab the latest code and documentation for 3.0 there. And that will have major updates done to it the next week. And time for demos and probably questions pretty soon. So over here we have a poor little VMware system running Windows 2000 Service Pack 4, and it has a nice happy flower background. It doesn't know what's about to hit it, so don't tell it yet. Happy little desktop, and we go back over here, and then we load the Metasploit console. And you wait, because it's 100,000 lines of Ruby and it takes a while to load. So, sorry. There we go. So as you can see, we have 186 exploits, 104 payloads. So all kinds of crap. And the console has complete tab completion. So once you get good with the console, you can do just about anything in about 4 keystrokes. So let's say I want to exploit one of the SMB vulnerabilities on that target system. So use XP tab exploit Windows SMB. Here's my SMB exploits. Now I want MSL5 PND. Okay, here's my exploit. What kind of exploit is this? So we've got a bunch of targets. I wrote this exploit, Frontline did too, some different options and so on. We're going to use regular Windows command shell. There we go, shell, and I want to be a bind shell and use TCP. Then I want to show my options again. Now, okay, I need to set the rhost variable, which is what target to go exploit, and then I need to set the lport variable to what port I want to use. And it defaults to port 4444, which was my favorite port until Blasters stole my shellcode, and now it's blocked everywhere. So we've got to change to something else. I'll never guess that. All right. Save configuration, type exploit. I'm sorry, we've got to set the rhost still. A target system's running in, the private VMware address. Going to main tool. All right. Command shell. So it's not very exciting. It goes really quick. And since our exploits are cool, you can keep running them and again. And you can background an exploit, and then you can look at the sessions in the background, and then interact with one, get yourself back again, So you can then kill it. And now instead of that really boring payload, let's use the VNC injection, because it's lots of fun. And we're going to use bind shell again to transport the DLL. And we're going to use a different port for it. And we run the exploit again. And now we're just going to sit back, wait for the DLL to upload and VNC to start. And there we go. The neat thing about the VNC exploit is even if nobody's logged into the system, this command shell will still show up, even if you're at the please login prompt. And if you're at the please login prompt and this blue Metasploit courtesy shell pops up, you can type explorer.exe and it will start up an entire desktop on the login screen. So someone locks their screen and they walk away, and then they come back to their system, and all of a sudden there's this command shell open and all kinds of crap going on, and they never even logged in. And the funny thing is they can still control, delete, and then log in, and they go to their real desktop. And then when they log out, they go back to your desktop. So it's fun to mess with the admin's mind this way. So this is one of the fun exploits. And now we're going to try it again. This time we're going to use the interpreter payload, which is the fancy do everything one. So Windows interpreter bind TCP set of ports. And that's really how easy it is to use. There's no tricks to that. That was start, go, run, exploit done. It's really about 10 seconds once you get fast with it. So now we're going to run the interpreter, wait for it to upload, and now we have a new shell with new fancy commands. This is things like, interact with the channels, edit stuff, download stuff, etc. So if you ever wanted to run VI on a system, a Windows system, you can now do that through Interpreter. Actually, when my little sister's computer breaks down, I send her an executable with Interpreter inside of it, and I use that to fix her system. Because it's so much better than anything else out there. So let's say I want to modify the boot ini file. That is edit boot.ini. It downloads a copy, brings it to my local system, opens up my editor based on my editor path, lets me change anything I want to in the system. Editor, hello, and then I save it, and it failed because I suck. There's probably a bug there. But normally it saves it, uploads again to the system, and then you're done. And you can just kind of edit files just like you're on a regular shell on Windows. So, anyways, this is this interface. There's also a couple of cool commands like idle time. It'll tell you how long the system's been idle, so you can wait until the administrator goes away and gets coffee before you start tearing apart the system. So now we see he's been gone for 1 minute, 27 seconds. And you can also do things like with the UICTL command, which will actually lock the administrator's keyboard and mouse out. So you can say, sorry, my system now, don't touch it. And you can kick them out completely and just take it all over. So anyways, that's the console. It's really easy to use. I won't do too many other demos of that, but I want to show one more thing. So just type MSF Web, and you need to have all the Rails stuff installed for Ruby on Rails. And we decided it was a really easy, quick way to basically bootstrap this thing and get it going. So this creates a new web server on port 55555, localhost. And wait for Mozilla, and start it up. So this is it. You have a nice console with all these different options. You click on exploits, and you have a little AJAX search form. So you can say, I want to exploit with decom vulnerabilities. So I can't say. So decom. Yes, decom, thank you. And bring up this exploit, and you can say, okay, here's some information about it. I want to use this target. And then pick your payload with all the nice descriptions. Let's see, where's interpreter? Here we go, interpreter, find. And then we have all the different options for running that exploit and doing everything here. And you can launch exploit if you want to. One of the problems we ran into when doing the Metasploit on Windows is that the standard I/O on Windows, you can't do a select on. There's no way to do a non-blocking poll of standard I/O on Windows without using Sigwin, without using these really cryptic Microsoft APIs that really don't work right. So we decided, screw it. Windows users don't get a fancy console. If they want tab completion, they got to use the web interface. So that means we had to write a tab completion console for the web interface. So now we have it. So you can open a bunch of consoles. Each one actually works fine. You can do, full tab completion via AJAX. So exploit, Windows, tab, DCRPC, tab, all that stuff. So let's do it again. Now let's use the net API exploit, which is MSO 640. So you change our prompts. We set our host to be 172.16.233.128. We see what payloads we can use with this exploit. A whole lot of them. So we can use a regular bind shell here. So we do Windows/shell and bind, and it all autocomplete just like it would in the console. And it's all done via fancy Ajax and JavaScript and all that. Now we just run our exploit like normal. And we have a regular command prompt, just through the web interface. And it's a little bit slower, there's some latency involved because Rails sucks basically, and WebRig has major problems with concurrency and multiple threads. But one of the neat things about this is you can actually detach a console here, and instead of running the web server on 127.0.0.1, you can open up to the world, and all your buddies can come into your system and exploit the crap out of something and share your shells. So let's say I'm my buddy, and I come by and I click on sessions. I say, oh look, I want to play with this command shell that my buddy already got. Click. So there we go, we have the shell. And when we're done, we can detach it and let someone else play with it. And you can actually forcibly detach them and share them and everything you'd probably expect from that. That's about all there is for the web interface and most of the talk. Any questions? Yes, sir. So the question was, do we have many exploits for Vista? And the answer is, we've reported a bunch of vulnerabilities in it. We're waiting to see when they're going to get fixed, and then we might release our exploits for it. So yes, we have exploits for Vista, but they're not public yet. So Vista isn't really that much different, especially when it comes to heap filling exploits, where you don't have to guess the address. You can basically just fill up a bunch of memory and jump into it. It's pretty straightforward. There's really no difference. Yes, sir? Okay. So the question was, do we audit our contributed code to make sure it doesn't have backdoors and things like that in it? And yes, we do. Most of our contributors have to supply patches to us for about 4.5 months before they ever get CVS access. And at that point, we usually know their full name, where they live, their social security number. So if they try to screw with us, we will go get them. So I'll put it that way. Yes, we're really careful about that because we have something like 90,000 users updating Metasploit every single month through our web server. And it would be a real shame if someone backdoored our update repository and owned all those government clients that blindly update every night. So, yes. Yes, sir? The question was, doesn't Vista have ASLR, or address space layout randomization? Yes, it does. But the addresses we care about are the DLLs and executable addresses, which are only randomized by 8 bits. So it's only 256 possible values for a DLL, and only every time the system boots the randomize, and all applications have the same address. So if you can find a way to leak an address from one application, you can then use that to exploit another application after you know where that DLL lives. And the NetBIOS protocol via the SMB service, the Win service, and many other services will leak the addresses of in-memory addresses. So there's ways to leak the addresses and use those to exploit it. So yes, it does make your exploits harder to make them reliable, but it doesn't really make much impact on exploiting them in the first place. You can still do it if you know where to go. Yes, sir? So given an arbitrary daemon that accepts connections and has some kind of service, is there a methodology for testing that service to find vulnerabilities? And there's a lot of them. There's no real way to say one's better than the other. My personal method is I'll open up this executable itself or look at the source code and kind of get a feel for how it works, and look at like IDAPRO or another disassembly tool, and look at starting at the receive function, see how it processes data, and then I'll go at a little quick fuzzer for that in Ruby or something that sends bad data and try to see where it ends up and what it does. But I'm probably not the best vulnerability finder out there, but I find enough to write lots of exploits. So, sorry. Sorry. The target machine, was it patched? No, it was Windows 2000 SP4, and that was it. It was supposed to be wide open, just for the demos. Yes, sir? So how easy would it be to build scan tools into Metasploit? And we already have some available. They go into the auxiliary directory, So the auxiliary modules do things like discovery, port scanning, fingerprinting. So any kind of, you can make Nessus out of Metasploit if you want to, just by adding enough discovery modules to it. So. So do we have any opcodes or addresses we can use for non-Windows versions? Yes, we just started adding them. The problem is there's so much data. Our database basically grows by a factor of like 10 by importing all these international versions. And although it's easy for us to get the addresses for all the different service packages we can download those, getting the original OEM install of a given operating system is difficult for us because we don't have the media. So at some point we may ask for donations, people send them all in, but if Vista and everything else starts randomizing addresses, they become less useful. So that's it. There's a question over here that's been waiting. Yes, sir? Has Metasploit ever been successfully used against my own systems? Actually, Metasploit was used against me on one of my own systems, but it was luckily used from a friend of mine. He found a way to take the public MSF web demo we run on Metasploit.com and bypass the safe mode and run exploits from our server. And using those exploits, so some of our payloads allow you to do things like upload files to a server that you broke into. And so he set up a fake target, used our Metasploit to break into his target, and then uploaded local files from our server to his remote system via Interpreter. So great. Luckily, he's a friend of mine. And that was Dino Daizovi, who works for Amatasano. And really nice guy, and he didn't own the crap out of us too bad. And yes, we learned our lesson. So yes, it has happened. Yes, sir? So the question was, have we tried Metasploit against a well-known IPS product, and how did that rate? The problem with that question is that's what I do for work. And so all of my testing is actually against real IPS equipment given to us by vendors. So I can't tell you too much about how well they work. What I can tell you is about a year ago, before I started that job, most IPS products would allow most exploits through with minor changes. And out of the last year, they've been improving them a whole lot, but the number I can give you is, if you look at all the top IPS products, and you look at our current exploit set, and if you do enough evasions using the features available that without having to add any new code whatsoever, you can basically get everything but 5% of the exploits through. So 95% bypass rate with all the popular IPS products. Yes, sir? So the question was, how many exploits are for non-Windows? Unfortunately, that number is really small now because I have to finish porting a whole bunch of Unix ones. I think there's probably 30 or 40, and it's going to get better. The web applications alone are going to skyrocket the number, and I don't really want to count those because all those PHP vulnerabilities, there's like thousands of them. But we plan on getting, I've got a whole test lab with IRX, Solaris, AIX, HBox, so we need to finish writing our exploits for those. The problem is that most of them, there isn't much demand anymore. Most systems people are doing pen tests against are Windows-based, and no one really cares if you have an HBox exploit for Samba. So that's really it. It's mostly been motivation. Like, people will say, do you have an exploit for this? And this is rarely not a Windows system. So we want to increase that because it sucks being all these Windows exploits on a Unix tool, but that's what people have been asking for. Are we on time? Good? Okay. Yeah. One question? Okay, we have time for one more. Yes, sir. The question is, are we dealing with, do we write exploits and support systems that aren't well known? Things like, was it i5? Or, AS400, things like that. And the response is, if we have a system to test, if we have a way to write exploits, we'll do anything we can for it. It's been a question of really just, do we have the time, do we have the equipment? If someone sends us an exploit for AS400 to bypass, telnet authentication, or an exploit for OpenVMS, we definitely take it. However, when you start getting to buffer overflows, things like that, before we can really support a new platform architecture, we need to have encoders, we need to have NOPs, we need to have all these other things need to be finished and done that really make it a lot more work to support a platform than is usually apparent. And I think that's all time for questions. Thank you again, great audience. Appreciate it.